Okay, this video will be page 9. All right, the next few pages are the trends of the periodic table. You're going to have a quiz on all these trends. You must know what happens, what increases, what decreases, what remains the same as you go across a period, or horizontal row, as you go across left to right, as you go from right to left. Across the period, you must know what increases or decreases, what remains the same, and as you go down a group from top to bottom, and as you go up a group from bottom to top, what increases, what decreases, what remains the same. But for page 9, we're just going to focus on what happens as you go left to right across a period. So we're going to start from the left and go to the right. All right, so we're going to focus on, we're going to use one, I'm going to choose one period, I'm going to choose period 3. So period 3, starting with NA, I'm going to go from NA across period 3 from left to right. I'm going to stop at CL. I don't like to count group 18 because they're non-reactive. All right, so I'm going to go from NA, then MG, AL, SI, P, S, CL. So what happens as you go from left to right across a period? And I chose period 3. All right, and you should take a note of where I get the information from. Okay, and you should have your reference tables handy. All right, so the first one is atomic number. All right, so next to atomic number, you might want to write in parentheses periodic table, PT, and table S. So sometimes you can find the answer for both. All right, so here I am. Again, I'm going to go from NA, we're going across period 3. So we're going from atomic number 11 to atomic number 17. So what's happening to atomic number as you go across the period? 11, 12, 13, 14, 15, 16, 17. It's increasing. Okay? And you can also see that on this table also. Right? 11, 12, and so on. It's increasing. Okay? So next to atomic number, draw an up arrow, increase arrow. Next one is nuclear charge. You should already know that nuclear charge is the same thing as atomic number. So Na, the nuclear charge is positive 11 for 11 protons in the nucleus. Magnesium is positive 12, right, for 12 protons in the nucleus. So the nuclear charge or number of protons, same thing as atomic number, so that also increases. Draw an up arrow, and that's found in both tables also. Nuclear charge is important when we get to atomic radius. Okay? All right. Next one is valence electrons. We should already know what that is. Valence electrons, that's only on the periodic table, so I'd write PT next to that. All right, so Na has how many valence electrons? 1. Remember the last number in the electron configuration. Mg, 2. Al, 3. Si, 4, and so on. P, 5. What's it doing? Increasing. So draw another increase arrow. Okay, next, ionization energy. Go to table S. Ionization energy. Let's go a little bit more. Okay. All right, this column here is ionization energy. All right. So we're going from sodium down to chlorine. All right. So remember, numbers 11 through 17. What's happening in ionization energy? 496, 738, 578. Went up and down a little bit. For the most part, it's going up. 787. 10, 12, 1,000, 1251, or 1521. So what's it doing? It's generally increasing. Okay? You have to know why later on. Why is it increasing? So draw an up arrow and write table S. Ionization energy increases. Okay? Next column, electronegativity. Yeah, starting with Na, going across the period to Cl. 0.9, 1.3, 1.6, 1.9, 2.2, 2.6, 3.2. What did it do? Increased. Okay? All right. Why is ionization energy, electronegativity increasing? Why is it increasing as you go left to right? Right? Because the next two things, actually, you need to add this in, because I skipped one. You need to add this into your packets. I forgot to write it in. Add the word, underneath electronegativity, add in the word atomic radius. Atomic radius. Okay? And for atomic radius, okay, atomic radius is going to be the last column. All right, so you have to scroll over to the last column on the table S. Okay, there's atomic radius. Okay? And what happens is you go from left to right. Again, we're going to go from sodium down to chlorine on the atomic radius. All right, so sodium is right here. 160. Next one, 140, 124. And 160, 140, 124, 114. All right, so you can see it's going down. Okay. All right. So the atomic radius is decreasing as you go from left to right. Okay. 160 down to 100. It's decreasing. All right, so we're going to draw a decrease arrow for atomic radius. Now, next two, again, you have to know your metals and nonmetals. So we're starting with Na. We're starting with Na, which is a what? A metal. And we're going left to right, so we're eventually going to end up at what? The nonmetals. So if you're going left to right, you're getting more metallic or more non-metallic. You're getting more non-metallic, because I'm moving away from the metals, I'm going towards the nonmetals, which are on the right side of this staircase. Okay, so for metallic character, metallic properties, you're going to write decreases because you're going away from the metals. You're getting less metallic as you go across. And you're getting more non-metallic, more non-metallic. So next to non-metallic properties, or non-metallic character, you draw an increase arrow. Okay? Okay, so as you go from left to right, you get more non-metallic. Okay? And if you're getting more non-metallic, that's why ionization energy increases. It's harder to remove an electron. And it's why electronegativity increases. God have you. Why? Because you're getting more non-metallic as you go left to right. Alright, so now the question's on the bottom of the page. First one. Why does the ionization energy increase as you move from left to right across a given period on the periodic table? Okay, so why does ionization energy increase as you move from left to right? Alright, because you're getting more what? Non-metallic. Alright, so you're going to write the following. Because you are getting more non-metallic, and nonmetals want to gain electrons, so it takes a lot of energy to remove an electron. Okay. You're getting more nonmetallic, and nonmetals want to gain electrons, so it takes a lot of energy to remove an electron. Okay. So you're starting with Na, low. Mg, a little bit harder to remove. Al is the next element, a little bit harder to pull it away. Si, eventually getting over to nonmetals where it's impossible to pull it away. Right? So that's why, again, because you're getting more nonmetallic and nonmetals want to gain electrons, so it takes a lot of energy to remove an electron. Next question. Why does the electronegativity increase as you move from left to right across a given period on the periodic table? What is electronegativity? The ability to gain electrons. Do nonmetals want to gain electrons? Yes. So the answer is because you are getting more nonmetallic and nonmetals want to gain electrons. Because you're getting more nonmetallic and nonmetals want to gain electrons. Okay, for the final question, this is something new now, and you have to know this. Remember, the only two things that decreased from left to right were metallic character and atomic radius. Why is the radius getting smaller? Right, as we have to know. Why does the atomic radius decrease as you move from left to right across a given period on the periodic table? All right, it has to do with nuclear charge. Right? It has to do with the number of protons or the nuclear charge in the atom. Okay, so, all right, if we go over to Na. How many protons does Na have? 11. It has a big atomic radius. And the radius can get smaller as you go across. Magnesium has how many protons, or nuclear charge of 12. So, since it has a little bit more protons, it's going to be smaller. Next one is Al, 13 protons, a little smaller. Si, 14 protons, a little smaller. Next one, P, 15 protons, a little smaller. Why? Because the more protons you get, it sucks in those electrons closer to the nucleus, making the radius smaller. Right? The number of shells is not changing. 3 shells, 3 shells. These all have 3 shells. Right? 281, 282, and so on. The number of shells is staying the same. But as you add another proton into the nucleus, those positive protons suck in those negative electrons from the outside, making the radius smaller. Okay? That's why the radius gets smaller as you go across the period from left to right, because you're getting more protons, nuclear charge, which pull in the electrons, making the radius smaller. So you're going to write, because the nuclear charge, or number of protons, is increasing, which pulls in the electrons closer to the nucleus, making the atomic radius smaller. Again, because the nuclear charge, or number of protons, is increasing, which pulls in the electrons closer to the nucleus, making the atomic radius smaller.